I'm going to go through the exact same problem example, solving it with completing the square versus the quadratic formula, just trying to connect these two strategies together. As a reminder, completing the square and quadratic formula are just two of the three methods we can use to solve quadratics. The other method is solving by factoring. Whenever we're trying to solve quadratics, our goal is to determine the solutions or the x-intercepts of the parabola. So let's start with completing the square. Whenever we're completing the square, we notice that our quadratic does not appear to be factorable. There is nothing I know of that multiplies to be 4 but adds to be negative 12. Therefore, we want to create a new c. As a reminder, this is A, this is B, this is C. Before we can create a new c, I need to move my current c to the other side of the equal sign using inverse operations, so subtracting 4 from both sides of the equal sign. Now I have x squared minus 12x equals negative 4. I'm leaving this space blank because that's where my new c is going to go. To get my new c, all I have to do is think about my current b. Right now, b is negative 12. So my b is negative 12. Now I need my b divided by 2. Well, negative 12 divided by 2 is negative 6. And then finally, I need to square the b divided by 2. Negative 6 times itself, negative 6 times negative 6 is a positive 36. Well, that means I'm going to be adding 36. However, this is an equation. It has to stay balanced. If I add 36 to the left, I have to add 36 to the right. So that gives me x squared minus 12x plus 36 is equal to 32. Now I have a quadratic that is factorable. I know that 6 times 6 is 36. However, 6 plus 6 is positive 12. So instead, I need a negative 6 because negative 6 times negative 6 is 36. Negative 6 minus 6 is negative 12. So my factor would be x minus 6 squared is equal to 32. Now, taking the square root of both sides, I get x minus 6 is equal to the positive and negative version of the square root of 32. As a reminder, the square root of 32 can be simplified because 32 has a perfect square factor. I know that 32 is divisible by 16, and 16 is a perfect square. Therefore, this is the same thing as the square root of 16 times the square root of 2, which is 4 square root of 2. So then now I have x minus 6 is equal to the positive and negative 4 square root of 2. Using inverse operations, I need to add 6 to both sides of my equal sign. And I have x is equal to 6 plus or minus 4 square root of 2. So this is solving it with completing the square. Now, let's look at this exact same problem, but using our quadratic formula. Our quadratic formula says that our solution is equal to negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. So it's helpful if we start by identifying our a, b, and c. For this, I know my a and b and c. I have a is 1, b is negative 12, and c is 4. So then now I'm going to start by just plugging these things in. So my x is equal to negative b. Well, b is already negative 12. So negative times a negative is a positive. So that would be 12 plus or minus the square root of b is negative 12 squared minus 4 times 1 times 4. And all of that is being divided by 2 times 1. Now I'm going to gradually simplify this. So I have x is equal to 12 plus or minus the square root of negative 12 times negative 12 is 144 minus 4 times 1 is 4 times 4 is 16. And all of that is being divided by 2 times 1 is just 2. Okay, next, 144 minus 16 is 128. So I have x is equal to 12 plus or minus the square root of 128 over 2. Okay, here's where I'm going to start simplifying the divided by 2, but it's going to happen in steps. So for starters, 12 divided by 2 is 6. So I have x is equal to 6 plus or minus the square root, hang on, let me move that. The square root of 128 divided by 2. Okay, now I'm going to simplify my radical. So factors of 128, if you're unsure, you can use your calculator. You can do y equals 128 divided by x. And I found that 128 is divisible by 32 and 4, which is good because 4 is a perfect square. So then now this is the square root of 4 times the square root of 32, and the square root of 4 is 2. So this is 2 square root of 32. And that's going to help us because we have a divided by 2 on bottom. So 6 plus or minus 2 square root of 32 divided by 2. Well, 2 divided by 2 is just 1, so it's like those cancel. So now I have my 6 plus or minus the square root of 32. Well, this is looking familiar. Where did it go? Oh, I simplified it before. We already know that the square root of 32 simplifies to 4 times the square root of 2. So now I can say this is 6 plus or minus 4 square root of 2. And here you have both methods side by side. Same answer, just different ways of solving. There is definitely times when completing the square is easier. There's definitely times that quadratic formula is easier. I just wanted you to see them both being worked out using the same example problem side by side. That way you can kind of connect it.